All right, so let's look at some examples, just like we did with the equations. We're kind of building ourselves up a little bit. Let's look at some examples involving the inequalities where we have to isolate the absolute value first, because that can throw some extra details in there. We'll look at that and continue to develop this idea. So first example, we have 6 times the absolute value of negative 5n plus 7 is greater than 37. We need to begin by isolating that absolute value. We've got to get it completely by itself before we can split it into its 2 cases, just like we did with our equations. So our first step to isolate, you do the order of operations in reverse order. It's just like if you're solving an equation. You're trying to get to that variable. You're trying to get that variable by itself. It's stuck inside that absolute value, so we got to start by getting that absolute value by itself. So we're going to start by subtracting. You always add or subtract first if applicable. So when we subtract 7, that makes us greater than 30. Then we multiply and divide. So we divide both sides by 6. The absolute value of negative 5n is greater than 5. Now we have our 2 scenarios. Negative 5n is greater than 5. Keep everything the same. Then for the other case, we keep it, we switch, and we switch the sign. Bless you. Now we solve those 2 inequalities. Don't get in a hurry with this, because inequalities introduce more opportunities to mess up a little bit. We divide by negative 5. Dividing by a negative, what does it do to an inequality? Flips it, changes it. So now we're less than negative 1. Let's go ahead and put that on our number line. Open circle at negative 1. Less than is to the left. L, less, left. Okay, goes together. Solve the other one. Divide by negative 5. Flip that inequality because we divided by a negative. Negative 5 divided by negative 5 is positive 1, so n is greater than positive 1. Greater ends with an R. Go to the right. Okay, interval notation. Again, remember, I think it's helpful to put those infinities at the end. Negative infinity on the left, positive infinity on the right. So we're from negative infinity to negative 1, positive 1 to positive infinity. Parentheses around everything because we don't, infinities always have parentheses. We have open circles because we're not equal to. So parentheses on the 1 and the negative 1. All right, example number 10. Negative 1 minus 4 times the absolute value of x plus 9 is less than or equal to negative 21. So again, don't be tempted. Do not combine the negative 1 minus 4. Multiplication comes before addition and subtraction, so you'd have to multiply that absolute value before you could subtract the negative 1 minus 4. So, don't do it. Start by adding the 1s both sides. So negative 21 plus 1 is negative 20. Divide both sides by negative 4. We're dividing an inequality by a negative. That means we've got to flip it. Flip a couple of times in this one. Okay. So we've got to flip it there. Now we've got our 2 cases. X plus 9 is greater than or equal to 5. X plus 9 is less than or equal to negative 5. Keep it, switch, switch. Subtract 9. X is greater than or equal to negative 4. So greater than or equal to negative 4. That's to the right of negative 4. Subtract 9. X is less than or equal to negative 14. Less than, left. Got another two inequalities. There are two intervals we have to write. Negative infinity to negative 14. This time we have a bracket because it was equal, and another bracket because it's equal to negative 4. Just as a little bit of a side note, as you're doing these, you won't always get whole numbers for the answers. Most of the time you will. These problems are designed to produce whole number answers, even though that's not very real world. Unfortunately, the real world is not full of whole numbers. But as you're doing these, if you get fractions like here, I'm thinking about if you had combined the negative 1 minus 4 and got negative 5 and then tried to divide by negative 5, you would have gotten a fraction. Negative 21 is not divisible by negative 5. So that's just a little bit of a tip off that maybe I did something wrong. I need to go back and look and see if I took the right steps. Okay. You may get fractions as your answers, but most likely you're not going to have fractions within the problem itself until you get to that answer. Most likely. Yes, sir.
So you added plus 1 minus 1, so why wouldn't you divide by regular 4 instead of negative?
Because that negative is still right there. The negative's attached to each of those numbers has a negative. Okay, so I added the 1 because it was a negative 1. Negative 1 plus 1 is 0. So that minus in front of the 4 still stays with that 4. It's separate from the minus with the 1. Okay. Any other questions? Am I going too fast? Okay. All right. So get 2 more and then you get to practice. Okay. 3 times the absolute value of 8x plus 5 minus 9 greater than or equal to 24. Okay, so start by adding 9 to both sides. 3 times the absolute value of 8x plus 5 greater than or equal to 33. Divide both sides by that 3 in front. We divide it by positive, so we don't have to change anything. 2 cases. 8x plus 5 greater than or equal to 11. 8x plus 5 less than or equal to negative 11. Keep it switch, switch. Subtract 5, 8x greater than or equal to 6. Divide by 8. I'm running out of room. 8 is greater than or equal to 6 over 8. Both divisible by 2 3/4. So that right here, greater than that. On the other side, subtract 5, 8x less than or equal to negative 16. Divide by 8, x is less than or equal to negative 2. Okay, I didn't flip the inequality there. Just reminding you, I didn't divide by a negative number. I was dividing a negative by a positive. Okay, it's what you're dividing by, not what is being divided. So x is less than or equal to negative 2. So I stopped my shading here when I was doing the 3/4 just in case my other answer was on the other side of that. In case you're wondering what I was doing there. It's just a little precaution. So from negative infinity to negative 2, anything in between there will satisfy that inequality. And from 3/4 to positive infinity. So again, let's talk really quickly before we do this last example. Let me remind you what this actually means, what these intervals mean. It means any number that falls in either of these intervals will satisfy that inequality. So that's another way you can kind of check your work, not just by plugging in the negative 2 and the 3/4, but to see if you got your inequalities in the right direction. Somebody give me a number that's between negative infinity and negative 2. Negative what? 4? Negative 4. All right. Let's go with negative 4. So let's plug it in. 3 absolute value, 8 times negative 4 plus 5, close it, minus 9. And if negative 4 works, that this number should be greater than 24. It is greater than or equal to 24. So that means this inequality is in the right direction. You did pick the right direction for that because you picked a number that was in that interval and it satisfied the inequality. I can pick a number way up here and do the same thing. Plug in, I don't know, let's do like 25. Okay, plugging in 25 for x. That's definitely bigger than 24, right? Okay, so I just want to throw out what this really means. Okay, sometimes we kind of get lost in the math and we can do the problem, but we don't understand what our answer really means. So I wanted to mention that. All right, last one. Just to make sure we got all the details. Start this one by adding the 9 to both sides. 4 absolute value, 9 minus 3n, less than 84. Divide both sides by 4. Absolute value of 9 minus 3n is less than 21. 2 cases. 9 minus 3n less than 21. Keep it. Switch. Switch. Greater than negative 21. Subtract the 9. Negative 3n is less than 12. Divide by negative 3, so n is greater than, we divided by a negative number, so it's greater than negative 4. I have a feeling this is going to be one of the ones that's in between, so I'm not going to shade too much yet. Subtract 9 from both sides, negative 3n is greater than negative 30. Divide by negative 3, so flip the inequality, n is less than positive 10. So we're greater than negative 4 and we are less than positive 10. So we are in between. Anything between negative 4 and positive 10 will satisfy that inequality. Anything between negative 4 and positive 10 will satisfy that inequality.